In a rectangle, inscribe a semicircle along one of its sides. Then inscribe a circle that's tangent to both the semicircle and the rectangle. If the semicircle has a radius equal to a, and the circle has a radius equal to b, what is the value of a divided by b? Pause if you'd like to give this problem a try, and when you're ready, keep watching to learn how to solve this problem. First, recall that if two circles are tangent, their centers and the tangent point are collinear. This is because each circle's radius is perpendicular to the tangent line. Therefore, ACB will be a straight line segment. This is true for both externally and internally tangent circles. Now, to solve the problem. Connect the center of the semicircle, the tangent point, and the center of the inscribed circle. Notice this will be a radius of this small circle, and we will also create a radius of the small circle by creating the tangent line to the other side of the rectangle. If we extend the diagonal of the square to the corner of the rectangle, it will also be collinear with the line we just created. Therefore, we've created an isosceles right triangle where two legs are equal to b and the hypotenuse is equal to b times the square root of 2. The radius of the semicircle is equal to a, and therefore we have another isosceles right triangle, so its hypotenuse will be equal to a times the square root of 2. Notice we also have a radius of the semicircle right here. We'll now focus on just these triangles, and in particular, we'll focus just on the hypotenuse. The entire hypotenuse has a length equal to a times the square root of 2. This will be equal to a plus b times the square root of 2. We then subtract a from both sides of the equation. We then factor on both sides. We then divide both sides by b and both sides by the square root of 2 minus 1. We thus get that a divided by b is equal to the square root of 2 plus 1 all over the square root of 2 minus 1, which is approximately equal to 5.828. And that's the answer. It's a cute little problem, and I think it's fun to solve.